Alright, so today we're going to start section 7.1, which is looking at exponential functions. So we want to recognize, evaluate, and graph exponential functions of base A and base E, and we're going to look at some applications. First, we're going to start off with a would you rather question. So, would you rather have the ability to fly or have the ability to turn invisible? Pause the video, think about it, unpause it when you're ready to check your answer. And the correct answer is no solution. Let's talk about that briefly. So, okay, let's say we chose fly. Well, we have to think about a lot of things first. What altitude are we flying at? Are we affected by temperature at extreme altitudes? How fast are we flying? Do we have the ability to carry others with us when we fly? So there's those type of things we want to think about. Turning it invisible. Let's be honest, we're not going to use invisibility for anything good. And then if we think back about the flying, we're probably not going to use the flying for anything good either. So in reality, neither one of these are going to benefit mankind if you have them as a special power. So therefore you should have neither, and that's why it's going to be no solution. Moving on. Next question. Would you rather have $100 a day or 1 cent the first day and then doubled every single day for a month? When we're saying month, we're going to talk about an average 30-day month. So pause the video, think about which one you would have, unpause when you're ready to check your work. Alright, so let's see how this works out. So after the first day, we have 1 cent or we have $100. $100 is looking good. After the second day, we have 3 cents because we got 1 on the first and 2 on the second, and we have $200. After the third day, on the left we have $300. On the right we have 7 cents. On the fourth day, on the fifth day, on the sixth day. So now on the sixth day we have, enough for maybe a stamp. So we could mail something to someone. Or we have $600. Let's move on down. And we look at the 10th day. So on the 10th day, on the left-hand side, we have $1,000. On the right-hand side, we have maybe about $10, give or take a little bit. So, you really probably can't go to a movie. Maybe you could if it was a matinee, but you're not going to buy any candy or soda. Then let's move on. So on the 11th day, here we have exact event numbers. So on the 11th day, we have $1,100 or we have $20.47. So now you can go to a movie. You could probably make it a 3D movie, maybe IMAX if you want. And if we continue to move down, on the 13th day, in the left-hand side, I have $1,300. On the right-hand side, I got $40.96 for that day, which brings me up to a total of $81.91. On the 14th day, I have $1,400 on the left side, and I have $163.83 on the right side. So at least now, I have some money that I can maybe do something with. On the 17th day, I have $1,700 in the left column, and I have $1,310.71 in the right column. But notice that I made $655.36 that day. So now is where things are going to start to turn. So on the 18th day, now I'm making some money in the right-hand column. So I have $1,800 or I have $2,621.43. And then as we keep moving down, we can see on the 20th day, we have $10,485 in the right-hand column and we have $2,000 in the left-hand column. Now, hopefully we chose the right-hand column. On the 28th day, you earned $1,342,177.28 in the right-hand column, and you still got $100 in the left-hand column. So, going down to the end, on the 30th day, we got $100 in the left. We got $5,368,709.12 on the right, just for that day, which brings us to a total of $3,000 on the left, or $10,737,418.23 on the right. So what is this? This is an example of exponential growth, which is an example of exponential functions, which is what we're going to be studying today. So, an exponential function of base a. This is a generic exponential function, f of x equals a to the x, where a is some number greater than 0 but not equal to 1, and x is any real number. So let's think about, why do we need the restrictions on a? So I want you to think about the restrictions on a, and while you're doing that, I also want you to fill out these properties of exponents. So pause the video, think about, why do those restrictions have to be on a? So there's our function, and then fill out the properties of exponents. Unpause when you're ready to check your work. Alright, so our restrictions on a, well, if a was 1, then f of x equals a to the x would just be a horizontal line at y equals 1, because 1 to any power is 1. If a was 0, it would be a horizontal line at y equals 0 for the same reason. If a was less than 0, it would not be a continuous function because it would keep jumping back and forth between positive and negative. So those are why we have our restrictions on a. So now let's look at our properties of exponents. A to the x times a to the y is a to the x plus y. A to the x over a to the y is a to the x minus y. A to the negative x is 1 over a to the x. A to the 0 is 1. A to the 1 is a. AB to the x is a to the x, b to the x. A to the x to the y is a to the xy. A over b to the x is a to the x over b to the x. And the absolute value of a squared is a squared. Alright, so now I want you to try and graph by hand f of x equals 2 to the x and g of x equals 3 to the x on the same graph. I want you to state the domain of each, the range, and identify any asymptotes and intercepts. Pause the video, do that, unpause when you're ready to check your work. Alright, so here I can see the domain for both of these is all real numbers. The range for both of these is 0 to infinity. Well, let's first talk about the domain. How do I know that? Well, there are no values that I cannot plug in for x. I can plug in positive, I can plug in negative, I can plug in 0, I can plug in fractions, I can plug in irrational numbers, and I'm always going to get an output in return. The range is 0 to infinity because I'm never going to end up with a negative value. No matter what I plug in for x, the output is always going to be positive. It's also never going to be 0. That means that I have a horizontal asymptote at y equals 0, and I do not have an x-intercept. The y-intercept for both of these is 0, 1. Here we can see our graphs. So the green function is the 2 to the x, the purple function is the 3 to the x. We can plot a couple of exact points by plugging in values. So I plugged in -1, 0, 1, 2, and then 3. And this is another example of exponential growth. So the 2 to the x is actually the exact example of what we had on the last problem with the money. So when we were doubling each increment, that's 2 to the x. So 2 to the x occurs if a is greater than 1. Alright, now I want you to try and graph by hand f of x equals 1/2 to the x and g of x equals 2 to the negative x on the same graph. Identify asymptotes and intercepts. Pause the video, unpause when you're ready to check your work. Alright, so hopefully you recognize that these are actually the same exact function. F of x equals the quantity 1/2 to the x is 1 over 2 to the x, and g of x equals 2 to the negative x is 1 over 2 to the x. They both have the same horizontal asymptote as the previous function, which is y equals 0. There is still no x-intercept, and the y-intercept is still 0, 1. However, the function now has flipped over the y-axis, so this is an example of exponential decay. So if a is between 0 and 1, that's when we're going to have exponential decay. And then again, we can find values by plugging them in to the function. Notice that the domain and range are the same as the previous two graphs here, and that is, unless there is some sort of shift, the domain is always going to be all real numbers and the range is always going to be 0 to infinity. The domain will actually always be all real numbers for any exponential function. The range will change with a vertical shift. Alright, so now without graphing these, I just want you to describe the transformation from f of x to g of x. So pause the video, describe the transformation, and unpause when you're ready to check your work. Alright, so hopefully we recognize this is going to be left 3 and down 7. We know that it's left 3 because of the quantity x plus 3 and down 7 because of the minus 7. So our transformations for exponential functions are the same as they were for all of our functions that we looked at earlier this semester. Alright, next we're going to look at the natural base, which is base e. E is a number. It is an irrational number. E comes from a few different things. You do not need to memorize or know any of these, but E can be written, or E can be developed from the sum from n equals 0 to infinity of 1 over n factorial. Once we get to calculus, we'll understand these next two a little bit better, but E is also the limit as n goes to infinity of 1 plus 1 over n to the n, and it's also the limit as n goes to 0 of 1 plus n to the 1 over n. Again, you do not need to know these per se or memorize them. It's just showing you some ways in which you can develop the number e. E then, or when we have a base e, we call it the natural exponential function. Here are a few other fun facts about e that you can peruse for your enjoyment. Aren't those wonderful? Alright, on to our next example. So I want you to evaluate for x equals 1.9, g of x equals negative 3e to the 2x minus 5. Pause the video, evaluate, unpause when you're ready to check your work. Alright, so all this wants us to do is plug in 1.9 for x, and then we can type this into our calculator. So we should end up with negative 0.9036. Now, if you're confused on how to type this into your calculator, I will show you that, or if you're having trouble with e. So we can do 2 times 1.9 minus 5. We get negative 1.2, so then I want to do e, which is right here. So if I do second ln, or if I do second division sign, both of those will give me e, and then I'm going to use my previous answer, and then times negative 3. So there we go. And then again, just to show you, if I wanted to just see what is e as a value, I can just do this and I get e. Or if I do second ln, it puts an exponent there right away, but e to the first is e. Okay, so I know there's still 2 minutes left on how much time I have, but there's a few more examples I want to do, so I'm going to stop this video here for part 1, and then we'll go on to part 2, or you'll go on to part 2 for the rest of your notes for tonight. So we're done with part 1.